Assalamu alaikum dear students. Welcome back to multivariable calculus series. In previous lessons, we learned about vectors, the dot product and the cross product. Today, we'll use these ideas to answer an important question. And the question is, how can we describe a line in three-dimensional space? So in two dimensions, we are familiar with equations like y is equal to mx plus c, where m is the slope or gradient of the line and c is y-intercept of the line. But in three dimension, a single equation is no longer enough. So instead, we use vectors and parametric equations to describe a line. So by the end of this lesson, you'll be able to understand the vector equation of a line, parametric equation of a line, symmetric equations of a line, and determine whether a point lies on a line and find the intersection of two lines. So let's start. We'll be covering section 11.5 in this video, which is parametric equations of lines. Well, imagine standing at a point in space. Suppose your starting point is P naught, and now suppose someone tells you to walk in the direction of the vector V. You can walk one step, two steps, half a step, or even backward. No matter how far you walk in the direction, you will always remain on the same line. So this is fundamental idea behind the vector equation of line. Okay, let's formally derive vector equation of a line which passes through the point P naught with coordinates x naught, y naught, z naught, and has a direction vector v. Then let's assume that P is any arbitrary point on the line and r naught be the position vector of P naught, r be the position vector of P, and then join P naught P to make vector A. Then by triangle law of addition of vectors, we can write r is equal to r naught plus A. So since A is parallel to, vector A is parallel to vector V, which gives the direction of the line. So there must be some scalar t such that A is equal to t times V. Then replace A by t times V in the previous equation. We have vector equation of the line r is equal to r naught plus tv, where v is the direction vector, r naught is a fixed point on the line, and r is the position vector of an arbitrary point on the line. And t is called parameter. So each value of the parameter t gives the position vector r of a point on line. In other words, t varies. The line is traced out by the tip of the vector r. So if t is greater than 0, then it moves us in the direction of the vector, and negative values of t moves us in opposite direction. And when t is equal to 0, we are at the point P naught, which is a starting point. So if we have vector v in component form and v is equal to abc, then we can write tv is equal to ta, tb and tc and plug in all these values into the previous equation. Position vector of xyz is the vector xyz. Similarly, position vector of the point x0, y0, z0 be vector x0, y0, z0. Then the equation becomes which was r is equal to r naught plus t times b. So this becomes xyz is equal to x naught plus ta, y naught plus tb, z naught plus tc. Since both the vectors are equal, so their corresponding components are equal. And this gives us three equations, like x is equal to x naught plus ta, y is equal to y naught plus tb, and z is equal to z naught plus ct. And these equations are parametric equations of the line which passes through the point P naught and parallel to the vector ABC. So each value of parameter t gives point xyz on the line. Find the vector equation. Let's understand the idea with the help of an example. Find vector equation and parametric equation of the line that passes through the point 513. That is x naught is 5, y naught is 1 and z naught is 3, and parallel to the vector I plus 4j minus 2k. It means a is 1, b is 4 and c is negative 2. So parametric equation would be, in this case, so first of all find vector equation. So vector equation, we know that is r is equal to r naught plus t times b. So r here is the position vector of an arbitrary point on the line. So this is equal to r naught here is the position vector of this point, which is 5i plus j plus 3k and plus t times, this is the vector b, I plus 4j minus 2k. So after simplification, we have this equation, which is vector equation of the line. And similarly, we can write parametric equation of the line from these components. It means x is equal to 5 plus t, y is equal to 1 plus 4t, and z is equal to 3 minus 2t. So for different values of t, we have point on the line. For t is equal to 1, now we have x is equal to 5, y is equal to 1 plus 4. So 5 plus 1, 1 plus 4, and 3 minus 2. So the point on the line becomes 6, 5, 1. Similarly, if we have another value like t is equal to negative 1, then this point will be 5 minus 1. Value of y would be 1 minus 4. And value of z would be 3 plus 2. So the point becomes 4, negative 3, 5. So this is how we can find different points on the line for different values of t. So the vector equation and parametric equations of line are not unique. So this is important to note. If we change the point or the parameter or choose a different parallel vector, then the equation changes. So for instance, if instead of 513 we choose another point 651, then the parametric equation of the line we have previously discussed becomes x is equal to 6 plus t, 5 is equal to y is equal to 5 plus 4t, and z is equal to 1 minus 2t. And in this case, we didn't change the direction vector. We can change direction vector as well, and we'll have a different equation again. So in general, the direction vector v is equal to abc is used to describe the direction of a line, and then the numbers abc are called direction numbers. Since any vector parallel to v could also be used, so we see that any three numbers proportional to these numbers A, B, C could also be used as set of direction numbers for the line. So another way of describing this line is to eliminate parameter t from the parametric equations. Parametric equations are x naught plus at, y is equal to y naught plus bt, z is equal to z naught plus zt. So this actually gives us t is equal to x minus x naught over a, and here we have t is equal to y minus y naught over b, and from this equation t is equal to c minus c naught over b. Since all these values right hand side of these equations are equal to t, so all these are equal. So if a, b and c all are, let me write c here, a, b, c all are non-zero, then we can write this line in this form: x minus x naught over a is equal to y minus y naught over b, c minus z naught, and this all of these are equal to t. So this is valid for the non-zero values of a, b and c. And in case one of the values is 0, still we can write this and eliminate t from these equations. For example, if we have a is equal to 0, then x becomes x naught, and we'll use rest of the values to describe the equation, like x is equal to x naught, y minus, and y minus y naught over b is equal to z minus z naught over c. So this is called symmetric equation of the line. So far we have learned vector equation of the line, parametric equation of the line, symmetric equation of the line. So find parametric equation and symmetric equation of the line passing through the points AB. Now we have 2 points. So in order to find the vector parallel to the point, parallel to the line, we need to find the vector joining AB. So that will serve as direction vector, and rest of the process will be same. So V in this case would be the vector joining A and B. That would be 3 minus 2. Components of these vectors are negative 1 minus 4. Similarly 1 minus negative 3. So this is the vector B, which gives us the direction vector. That is, A here is 1, B here is negative 5, and C here is 3. And you can choose any of the points A, B to be P naught. So if we choose point A, then x is equal to 2 plus t, and y is equal to 4 minus 5t, and z is equal to negative 3 plus 4t. And by eliminating t from these equations, we have this symmetric form. So the part B, at what point does this line intersect the xy plane? So at xy plane, z is equal to 0, right? So just substitute z is equal to 0. We have x minus 2 over 1, y minus 4 over negative 5 is equal to 3 over 4. So this gives us values of x and y when z is equal to 0. So x minus 2 is equal to 3 by 4. X is equal to 3 by 4 plus 2, and that is 11 over 4. Similarly, y minus 4 divided by negative 5 is equal to 3 by 4. Again, we can find value of y by making y subject. So we have y is equal to. So this is the point where line intersects xy plane, where c is equal to 0. Line segments. So sometimes we are not interested in an entire line, but rather some segment of the line between 2 points. So parametric equation of a line segment can be obtained by finding parametric equations for the entire line, but we restrict t in this case to find the segment. So in this case, t lies between 0 and 1. So like if we have to find line segment joining these 2 points, just find parametric equation of the line joining these 2 points as we did in previous example, but restrict t, so t can have values between 0 and 1 inclusive, and for these values of t, every point will lie within the line segment P1 and P2. So this is how we can find equation of a line segment. So sometimes in 3-space, sometimes lines are parallel, sometimes lines are not parallel, sometimes lines intersect, sometimes lines do not intersect. So if two lines are parallel, then their direction vectors are parallel. Or if their direction vectors are parallel, lines are also parallel. But sometimes there are lines who are not parallel and they do not intersect as well. Such lines are called skew lines. So lines are not parallel if their direction vectors are not parallel. That is, if their direction vectors are not scalar multiple of each other, then the direction vectors are not parallel. If direction vectors are not parallel, lines are also not parallel. So we have an example of two lines. These are the parametric equations of the line. So for this line, t is the parameter, and for this line, s is the parameter. So we try to find intersection of these 2 points so that we can prove whether we can check whether these lines intersect or not. For this, equate their corresponding values. X is equal to 1 plus t. So 1 plus t is equal to 2s. Point of intersection will be the point where x, y, z are equal for both the lines. So let's see if we can find any value of t or s for which x, y, z are equal for both the lines. So let's solve first two equations and to find values of t and s, and we'll check those if those values would satisfy this equation, third equation, then the lines intersect, and if those values of s and t would not satisfy this third equation, then the lines do not intersect. So from first equation, we have t is equal to 2s minus 1. So just substitute into the second equation, we have negative 2 plus 3 times 2s minus 1 is equal to 3 plus s. So by simplifying, we have t is equal to 11 over 5 and s is equal to 8 over 5. So if we substitute these values of t and s in third equation, we have 4 minus 11 over 5, negative 3 plus 32 over 5. And both are not equal. These two are not equal. So it means these two lines do not intersect. And to check whether these lines are parallel or not, just find out the direction vector. So for line L1, direction vector is 1, 3, negative 1. And for line 2, direction vector is 2, 1, and 4. So these two vectors are not parallel because they are not, we cannot write one vector in term as a scalar multiple of the other. So these two vectors are not parallel means these two lines are not parallel. So these are two lines which are not parallel, but they don't intersect. So these are skew lines. So this is how the lines looks like in space. So skew, if the lines are skew, it means they do not lie in the same plane, right? If they lie in the same plane, they are not parallel, they will intersect. But if they do not lie in the same plane, they lie in different planes, then they do not intersect and they are not parallel as well. That might happen. So that's all for today's lesson. Take care. Bye.